In this video, we're going to be learning about simple selection, and that means if statements, if-else statements, nesting, and Boolean operators. So a fork in the road. As previously stated, our program runs from top to bottom. Today, we'll learn how to make the flow diverge into multiple paths. Think of it like a train. So the train can only go forward when it comes to a choice in the tracks. It can only choose one of the paths to follow, so all others are forgotten about. A control structure is a programming element that allows us to change the flow of the program. Today, we're going to learn about a powerful control structure, which is the selection statement. So selection statements. Now selection statements are statements which the flow of the program will use to select a path based on if certain conditions are met. So selection statements come in four varieties in most programming languages. We have if statements, which give one option or a standard path. If-else statements, which give two options with no standard path. If-else-if statements, where there are infinite options and no standard path. And switch statements, which have infinite options and no standard path. We're going to look at those last. So if and if-else statements are considered simple selection statements. And if-else-if and switch statements are considered multi-selection statements. Let's take a look at some comparison operators. So to give us control over program flow, values are compared. And then if a desired condition is met, the flow will go along a new path. So in the below example, if the result is true, then the flow will follow the new path. So for each comparison, let's assume that x is equal to 5 and name is equal to Bob. So in the first row, we have the operator of equal equals. So two equal signs, and that means equal to. So if we are looking at the comparison of x equal to 5, so is x equal to 5? Well, that would return true. So if x equal to 5, then follow this path. That's the idea. If we're using strings, then we want to use dot equals. So then for a string like name, we would do name dot equals, and then we would put the string that we're comparing it to inside the brackets and inside the quotes. So is name equal to Fred? In this case, false. So it would return the value of false. When you have an exclamation mark and an equal sign, that means not equal. So our comparison here would be x not equal to 8. And that's true because it's equal to 5. Greater than is a comparison where we have the sort of triangular bracket that's larger to the left. And it reads it from left to right, so that x greater than 8, and in that case it's false. And then the opposite direction, less than, is x less than 8. That would be true. And then we can also include the equal sign so that it can be greater than or equal to. So x greater than equal to 8, false, and then less than equal to, so that less than or equal to x is less than or equal to 5. And since it is equal to 5, then this one would be true. Now an if statement where there's one option or it's just a standard path. So our general syntax is that we have if with a test condition inside the brackets, and then we have our curly braces to have a container underneath that for what we're going to do if this test condition is true. So inside these curly braces, you have the block of code that is executed if our test condition ends up being true. So normally we have a straight down path, but this actually gives us one extra option. So you can continue along in the program, or you have that option to move off that path. As an example, if we have a variable, an integer that's hour and it's equal to 23, and you have a string that's called greeting and it's equal to hi, our first condition here is that if hour is less than 18, and what do we want to happen if hour is less than 18? That goes inside the curly braces. Well, what we want to happen is that the greeting will change to good day. So, and then we have our output statement that will output the value of greeting. So what would be the output in this case? So is our test condition true or is our test condition false? And if you answered false, then you would be correct in thinking that the output would just be the word hi. So the original value of greeting goes unchanged and is outputted to the screen. For if-else statements, we have two options. So our syntax is very similar for the if portion, but we also have a second part, which is the else. So if and then else. That gives us a second option so that if the test condition is false, this part of the code will be executed. So we have our standard path, but then at this point, it branches in between the two. So if it's true, if the test condition is true, then the first set of code, or the first block of code will be executed. If the test condition is false, then the else block of code will be executed. So as an example, we look at our same program with the hour of 23 and our initial string. So if the hour is less than 18, then we're going to change the greeting to good day. But if it's not less than 18, this is where the else comes in, and the greeting becomes good evening. So if it's less than 18, then we say good day because it's bright and sunny out. But if it's not less than 18, then we would say good evening because now it's starting to get darker. And then finally, we output that statement. Okay, so what is going to be displayed in this case? So we know that 23 is not less than 18, so it's not going to be good day, but we have another option. So it goes to that second option, the else option, and good evening is displayed. Some notes. So the else acts as a catch-all. So in whatever has been tested above, this condition is everything else that's not actually tested. So hour less than 18 is tested and it's proved to be false, but every other possibility will fall under the else, which in this case just means greater than 18, but that's the idea. So for it being a catch-all, it catches everything else that is not actually being tested in our first statement. But note the lack of brackets and the test condition. So an else statement doesn't need it since it represents literally everything else. There's no condition after the else. And only one branch of code will be executed. So if the flow goes into the if statement, the else code is actually skipped. So if the test condition is true, then it would change the greeting, but the else is never actually checked. It's never actually run. So it's completely ignored at that point, and it would just go right to the output statement that follows our if-else conditions. This brings us to Boolean operators. So sometimes our choices are based on more than one variable. So for example, we may only want to calculate the area of a rectangle if both its length and width are positive numbers. So we can satisfy this need of double criteria in a couple of ways. The first is using nested if statements. So having an if statement inside of another if statement. So first, this one checks to see if the length is greater than 0. So then if that is true, it enters the block of code that's inside that condition. And then we have another if statement where if the width is greater than 0, and then if that is true, it enters that block of code to execute what's inside those braces, which in this case would be the area equal to length times width. Now with this set of code, if the first condition is false, then it skips everything inside that block of code. If the first condition is true, but the second condition is false, so it will still enter the first block of code for the first condition, but the second condition, if it's false, it will skip that block of code and it'll be completely exiting our conditions in this case. Another option is to create a compound if statement. So basically saying if two different things. So if this is true and that is true. Okay, there are other operators that we can use besides and, but this is what we would be looking for something like this. So this would be like combining two separate tests into one statement. So when we do this using Boolean operators. So there are three Boolean operators in most programming languages. There's AND, which in Java is two ampersands. So the two symbols that are above the 7 key on your keyboard. And this will be true if all of the tests evaluate to be true. So everything that follows on either side of that AND command has to be true for the entire condition to be true. There's also OR, so this is the two vertical lines that are above your Enter key, Shift and then pressing that key. This is true if at least one of the tests evaluate to be true, so you can have multiples of these separated by the OR command. As long as at least one of them is true, then the entire block of code underneath that will execute. And then we also have not. So in this case, it's an exclamation mark. So we saw this with not equal to. We can also use this with Boolean operators. So if this is true if the entire test evaluates to false. So let's take a look at how these work. So if we have x is equal to 6 and y is equal to 3. So for our chart here, the first operator is the ampersands, and this means and. So we want to check and see if x is less than 10 and y is greater than 1. Both of those are true, so then this would be true. The two vertical lines means or, so x is equal to 5 or y is equal to 5. And both of those are false, so the overall test condition would evaluate to be false. And the last one, an exclamation mark, the word not. So if we have x is equal to y in brackets, and we put the exclamation in front, now x is not actually equal to y, so inside our brackets would be false, but then the exclamation mark essentially means take the opposite result. So if it's false, then it would be true. So exclamation mark in front of this one actually gives us a result of true. And that would read as is x equal to y, or is x not equal to y? Okay, so it's not the result of x is equal to y. From the previous slide, we were looking at if length is greater than 0 and the width is greater than 0. So we had a nested if statements. Here we can put them both into one compound if statement. So we'll check if the length is greater than 0 and the width is greater than 0. Then it can do the calculation for area is equal to length times width. So let's see if we can get this one. So we can have multiple Boolean operators all in one line. We could have multiple variables that we're using to test those operators. So just for a very simple reason here, we're just going to use A, B, and C. And let's assume that A is equal to true, B is equal to true, and C is equal to false. So what would be the result of the following compound statement? So we have some brackets in here, so we have to make sure that we're using BEDMAS in order to complete this calculation, or in order to determine what this result is going to be. So we have A and B, and not, with a bracket, A or bracket, B and C, close bracket, and not B, and then a couple of close brackets. So let's go very slow through this, and we'll work our way out and come back and see what the final result is going to be. Okay, so thinking about BEDMAS, we start from the inside, work our way out, paying very careful attention to where the brackets are. So let's break it down. Working from the inside out, our first set of brackets would be B and C. Well, B is true and C is false. So we have true and false. Since both of them are not true, that would be equal to false. And then in our full statement here towards the right, we can replace where we were checking with F for false. Okay, so this was the B and C. We realize that true and false gives us false, so we've put an F in there. The next part, we have another set of brackets. So now looking at this line, we have this set of brackets that's on the inside. So F and not B. Okay, so B is true. So not B means false. So now F or false and false gives us false back because they're not both true. They must both be true, and these two conditions are false. So this returns false. So again, we can replace that part in our statement with just false. So now I still have a set of brackets, and it's with a not in front of it. So not a or false. Okay, well, when you have an or, then all you need is one of them to be true in order for that result to be true. So we have true or false because A is true. So that means the brackets evaluates to true, but the exclamation mark means not true. Not true is false. And then again, I'm replacing that spot in uh, our equation for the Boolean operators with false. And now we have A and B and false. Well, A and B is true, but F means false. So these are not all true, and our final answer is false. Take a look at all the examples that were presented here, and then if you have any questions, let us know.